Hello. Okay, we are starting chapter 2 now. A few things about this chapter before we get going. We are really diving into the meat of statistics now, so there will be a lot of numbers. If you're like me, you may have trouble keeping track when you're reading them sometimes. You don't have to do this, but if dyslexia or keeping track of a row of numbers gives you trouble, I would recommend investing in a cheap ruler. You can place it below the line you're on with one hand while you're writing or entering on your calculator with the other. Make sure it has 3-hole punches in it so you can put it in your notebook and carry it with you when you're coming to class or when you're doing the videos and lecture notes. Next, you will be using your calculator for this chapter. There are places on the lecture notes to write the commands, or you can do like I suggested for notation and have another section in your notes that's especially for calculator notes. I would suggest having some sort of title for what the commands do, then list the buttons to press, then perhaps a simple example to remind you when to use it. Also, when you come to the parts of the video that have calculator instructions, pause the video so you can see the commands and write them down for yourself. You have control over the video. Okay, this section has a little bit of notation, but the rest of the sections in this chapter will have a lot more. So it's time to get those notes going. Make sure to write the symbol, how to say it, give yourself hints like sounds like you, mu, what it stands for, and you can note in what types of formulas you see it appearing. Okay, this section essentially has two parts, frequency distributions and graphs. Don't get bogged down by it, just realize ahead of time that you're going to need to think during some of these. Last thing for this chapter, you're going to start having to think in terms of several steps for some of these problems. Sometimes you'll find one part of the puzzle which will lead you to another formula, which fills in part of a table where you get numbers for yet another formula, and so on. That is just part of statistics. Accept now that it's going to happen and prepare yourself for it. Take good notes and ask questions when you have them. Okay, let's get chapter 2 going. Good luck. Hi everyone, we're jumping into chapter 2 today with section 1, frequency distributions and their graphs. Chapter 1 covered a lot of the terminology and procedures used to collect samples. Our goal in this chapter will be to learn how to organize that data. We want to make data easier to understand by describing trends, averages, and variations. The best way to do this is to organize the data so that some sort of pattern or special characteristic is visible. So, our learning objectives will be as follows. Learn how to construct a frequency distribution, including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries. And learn how to construct graphical representations like frequency histograms, frequency polygons, relative frequency histograms, and how to create ogives using information obtained from a frequency distribution. Let's get started. Let's first discuss what a frequency distribution is. A frequency distribution is a table that shows classes or intervals of data with a count of the number of entries in each class. In some textbooks, you'll see classes referred to as bins. The frequency is denoted with the lowercase f. The frequency of a class is the number of data entries in the class. Here's an example of a frequency distribution. Examples are usually easier to understand when there's some type of context, right? So let's say this frequency distribution is cataloging the popularity of raffle ticket prizes at a carnival. For instance, look at the first row of this distribution. We might interpret this by saying that 5 people selected prizes valued between 1 and 5 raffle tickets. What you've really got to keep in mind about frequency distributions is that they're not often reflective of raw data points. I don't know if all 5 of these people got prizes worth 1 raffle ticket, like pencils, or 3 of them got 4 ticket prizes, or 2 got 5 ticket prizes. I don't know. Frequency distributions don't tell me that specifically. Frequency distributions simply provide organization. So instead of trying to look at all the prize values of all 36 carnival goers at once, with the frequency distribution, I can focus on the frequencies of smaller ranges of ticket values. Now each class in a frequency distribution has a lower class limit, which is the least number that can belong in that class, and an upper class limit, which is the greatest number that can belong to that class. Notice that the class values do not overlap, and that the mathematical difference between classes is always the same. We call that difference the class width. or more formally, the distance between lower or upper limits of consecutive classes. For example, I've marked the lower class limits of a pair of consecutive classes. The difference between them is the class width, as it is for all consecutive lower and upper class limits. The difference between the maximum and minimum data entries is called the range. That word will come up later, so make sure you understand that. Difference between maximum and minimum data entries is called the range. Okay, here are a few guidelines for constructing a frequency distribution. First, decide on the number of classes. In the real world, this is totally up to the statistician, but in our case, we will usually keep them between 5 and 20 classes. Otherwise, it may be difficult to detect patterns among them. For the purposes of this class, most of the time, you'll be told how many classes to create. Next, find the class width. This is done by first finding the range of the data, meaning subtracting the minimum entry from the maximum entry. Then, divide the range by the number of classes. Once you have a result, round up to the next whole number. Once you've calculated the class width, you then need to find the class limits. Use the minimum data entry as the lower limit of the first class. Then you find the remaining lower limits by adding the class width to the lower limit of the preceding class. Then find the upper limit of the first class. This would be one less than the second lower limit because, remember, the classes do not overlap. Of course, the next step is to find the rest of the upper limits by adding the class width to the first upper limit. Then make a tally mark for each data entry in the row of the appropriate class. Finally, count the tally marks to find the total frequency F for each class. It's pretty easy once you've practiced it, so let's try an example. The dataset lists the phone screen times in minutes for 30 U.S. adults on a recent day. Construct a frequency distribution that has 7 classes. Well, our first step is to decide how many classes, and that was given to us, so 7 classes. Next, we need to find the class width. Remember, this is done by finding the range of the dataset first. So identify the maximum data entry, in this case 405, and the minimum data entry, in this case 155, and find the difference. Then divide by the number of classes, 7. We get a result of 35.71. Remember, our last step said to round up, so we will use a class width of 36. We place the minimum value of our first lower limit. Then we add 36 to that number to get our next lower limit, 191. We continue this process until we get close to our maximum entry. Next, we subtract 1 from our second lower limit to get our first upper limit, then either add the class width to it to get the next upper limit, or refer to the lower limits and subtract 1 from each next lower limit to get the remaining upper limits. Find the rest of the remaining upper limits. Finally, it's okay for your last upper limit to be over your maximum data entry, but it should not be under it. If that's your result, you need one more row. Next, it's time to make tally marks for how often data entries fall within different classes, or to use academic language, how frequently they occur. Do this for all of your data entries. Next, convert this to numerical entries under the frequency or F heading. Other common features that provide better understanding of the data are midpoint, relative frequency, and cumulative frequency of each class. You'll often see these columns on frequency distributions. We'll start with midpoints. I think the term midpoint tells you how to find this figure. You add the lower class limit and upper class limit and divide by 2. For example, on our table, to get the first midpoint, we add 155 and 190 and divide by 2 to get 172.5. That is our first midpoint. Just like when we were finding the lower and upper class limits, we can add the class width to our midpoint to get the next one. So 172.5 plus 36 equals 208.5. That is the midpoint for our next class, and so on. The next feature that is useful is the relative frequency of each class. The relative frequency is the portion or percentage of the data that falls in a particular class. It is found by dividing the class frequency by the sample size. It is at this point that I want you to start paying attention to notation. If you have a certain place in your notebook or on your tablet where you can write these different symbols and what they stand for, it will save you a lot of time in the future because we will be using a lot of them. Here's our first use of them. We are using the lowercase f for class frequency and lowercase n for sample size. That E-looking symbol is the capital Greek letter sigma. That's called sigma, and it means sum. It is noting here that the sample size, or n, is actually the sum of all of the frequencies. For our note-taking purposes, lowercase f in frequency distributions is frequency, lowercase n is sample size, capital sigma is sum, and lowercase n, or sample size, is the sum of all the frequencies. So, to get the relative frequency for each class, we're dividing that class's frequency by the sum of all the frequencies. This will give us a decimal. The cumulative frequency of a class is the sum of the frequency for that class and all previous classes. The cumulative frequency of the last class is equal to the sample size n. Let's add all this information to the frequency distribution from our last example. Remember, frequency distribution means a table. So anytime you are asked to create a frequency distribution, I'm asking you to create a table. So the first two columns here are what we came up with previously. We found our class limits and tallied and found our frequencies f. The three columns on the right are what we've added. So let's look at the first class, 155 through 190. The midpoint is the physical middle of the class. So we found the average of each class using the upper and lower limits and dividing by 2. After that, in order to get the next midpoint, we could either do the same formula or we could just add the class width to it and get our next midpoint. Next is relative frequency. Think of this as the portion that each class takes out of the total sample. When we work with relative frequencies later, we sometimes use the percentage form of these numbers. So if it helps you to think in terms of percentages, you can do that. The first class takes up 3/30, or 10% of the total sample. We used the frequency of the class, in this case 3, and the sum of all the frequencies, 30, to find the relative frequency for the first class. Then we found this for the rest of the classes. Next, and finally, to find the cumulative totals, we simply started with the first frequency amount, then added to that each frequency amount as we continued down the table. You'll notice the final entry in the cumulative frequency column is the same as the sum of the frequencies. Here's what the finished frequency distribution looks like. Okay, we got a lot of information out of that table, frequency distribution, but we really start to see patterns and trends in the data set once we begin graphing. So let's look at some ways to graph frequency information. So we're going to explore 4 different ways to visually display this information. The first way is called a frequency histogram. A frequency histogram is a bar graph that represents the frequency distribution. The horizontal scale, that's going across, is quantitative, that means numbers, numeric, and measures the data values. The vertical scale measures the frequencies, or F, of the classes. Now, what separates a histogram from a typical bar graph is that the consecutive bars must touch. This means that bars must begin and end at the same point. We call those points class boundaries. These boundaries are created so that the data being shown on a histogram is continuous. Even though this particular data set has all whole numbers, that is not always the case. To construct a frequency histogram, we must first come up with those class boundaries. To get the first set of class boundaries, we need to figure out the distance between each upper class limit and the next lower limit. Well, when we did this previously, the difference was 1. We did that purposely. So now we divide that in half to get the end of our first boundary. That half distance is what we use to determine where the first boundary marker should fall. Since we're using a half point, we subtract 0.5 from the first lower class boundary and add it to the upper boundary. So our first set of class boundaries are 154.5 to 190.5. Because we want this to be continuous, our next set starts at the ending point of the first one. So our next set is 190.5, half a point less than the lower class limit, to 226.5, half a point above the upper class limit. Continue in this way until you have class boundaries for all classes. Remember, we're doing this all to set up a graph, namely the horizontal axis for a frequency histogram. You can either mark the midpoint of each class in the middle of your rectangles as shown on the left, or you can mark them as the left boundary of your intervals, where the left end of the rectangles touch those boundaries as seen on the graph on the right. They both show the exact same data, just represented slightly differently. The vertical axis is, of course, the frequency. Physically graphing the frequency distribution makes it easier for us to interpret the information after we have organized it. We can see now, for example, that 2/3 of adults are spending more than 262.5 minutes each day using their cell phones. Another way to visually examine a frequency distribution is to create a frequency polygon. A frequency polygon is a line graph. To construct the graph, we use midpoints and frequencies to create an ordered pair. Let's do this for the frequency distribution we've been working on. To construct the frequency polygon, use the same horizontal and vertical scales that were used in the histogram, but labeled with class midpoints. The midpoints and frequency create ordered pairs. As you can see, the first data point has the midpoint 172.5 and the frequency of 3. So the ordered pair 172.5 and 3, with the midpoint as the x-coordinate as it is labeled across the x-axis, and the frequency 3 is the y-coordinate as it is labeled along the vertical y-axis, results in the point being placed where you see it on the graph. Now note a special condition of this type of graph. The graph should begin and end on the horizontal axis. So make sure you extend the left side of the line graph one class width before the first class midpoint, and extend the right side to one class width after the last class midpoint, shown circled on the horizontal axis. Another graphical representation is a relative frequency histogram. It has the same shape and same horizontal scale as the corresponding frequency histogram. The only difference is that the vertical scale measures relative frequencies, not frequencies. Let's create a relative frequency histogram for the cell phone data we've been working with. Since we've already found relative frequencies for each class, we simply use those numbers as the vertical scale. You can either use midpoints or the class boundaries as your scale on the horizontal axis. And here you go. This histogram looks almost identical to the frequency histogram we created earlier. We can draw many of the same conclusions. We can see that about 2/3 of the adults are spending more than 262.5 minutes each day using their cell phones. But now that the vertical axis is reflecting relative frequencies instead of just frequencies, we can also make some proportional statements about ranges of values. For instance, we can see that 20% of adult screen time is between 262.5 and 298.5 minutes. Last but not least, let's talk about ogives. Ogives are also called cumulative frequency graphs because they specifically show information about cumulative frequency. An ogive is a line graph that displays the cumulative frequency of each class at its upper class boundaries. This means that upper class boundaries are marked on the horizontal axis, and the cumulative frequencies are marked on the vertical axis. Here's how we do it. To construct an ogive, begin by constructing a frequency distribution, that table that we've been working with, that includes cumulative frequency as one of its columns. Specify the horizontal and vertical scales. Remember, the horizontal scale is the upper class boundaries, and the vertical measures the cumulative frequencies. Then plot the points that represent the upper class boundaries as your x-coordinates, and the corresponding cumulative frequencies as your y-coordinates. Next, connect the points in order from left to right. The graph should start at the lower boundary of the first class, where the cumulative frequency is 0, and should end at the upper boundary of the last class, where the cumulative frequency is equal to the sample size. Remember, we use the upper class boundaries and their associated cumulative frequency as ordered pairs, starting at the lower class boundary of the first class, where the cumulative frequency is 0, then moving to the first upper class boundary with associated cumulative frequency as the next point, and so on. This is what it would look like. See how the graph starts at the horizontal axis at the point 154.5 and 0 and ends at the upper class boundary of the last class with the coordinate pair of 406.5 and 30, which is at the sample size? Ogives give us visual increases and decreases in the data sets by the steepness of the individual line segments between points. The slope of the lines tells us the rate at which the value changes as we read the graph from left to right. For instance, from the ogive, we can see that 10 adults had screen times of 262.5 minutes or less because that point represents an accumulated value. And the greatest increase in cumulative frequency occurs between 298.5 and 334.5 because that line segment has the steepest slope. Okay, now we're going to see how to create a frequency polygon on a TI-84 calculator. Start by pressing the Stat button and edit, select, and press Enter. Here you will enter the midpoints and frequencies. Now, before you get started with these, make sure you add a line to your table at the beginning that is one class width below the first midpoint with a frequency of 0. Then add another at the end that is one class width beyond the last midpoint with a frequency of 0 to have your beginning and ending points on the horizontal axis, because we're doing a frequency polygon that has to begin and end on the horizontal axis. Okay, now enter your midpoints in the L1 column, pressing Enter to progress between entries, and enter frequencies in the L2 column, again pressing Enter to progress. You will have to arrow over to L2 to begin entering those numbers. Pause the video so that you have time to do this. Okay, once you've entered all your figures, press the second button, then Y equals, and enter. Next, select the type of graph you want. You'll select the one that looks like a line graph with beginning and ending points on the x-axis. If you need to change the X list and Y list to reflect that you have data in the L1 list and frequencies in the L2 list, you may need to arrow to the correct line and press the second button and 1 for L1 and the second button and 2 for L2. Or you may have a different way of selecting L1 and L2. The calculator that you have may have different commands for that part. Once you've got those settings correct, press Zoom, then the number 9. That should display the frequency polygon correctly on your calculator, and your results should look similar to what we achieved here in the video. If you'd like to explore a little, you can press the Trace button, then your arrow keys to follow the path of the data points along the graph. Now what about a histogram? Let's learn how to do one of those on the calculator, shall we? The instructions for creating a histogram on a TI-84 are the same, except you do not add a line at the beginning and end with 0 for the frequency. In fact, if you'd like to use the numbers you entered for the previous graph, all you have to do is edit L1 and L2 to take out those entries. You do that by pressing Stat, select Edit, and then Enter. Then arrow down to the first entry and press the Delete button. It's between the Mode button and the arrow keys. Then arrow down to the last entry and do the same thing. Press the Delete key once you have it highlighted. Then arrow over to L2's first and last entries and press Delete for each of those, and you should see it move up so that it is lined up the same with L1. Okay, now you display it by pressing the second button and the Y button and press Enter. Then arrow over to and select, by pressing Enter, the little picture of a histogram. You'll see the bars touching. Then, as before, if you need to change X list or Y list for your calculator to recognize you want to use L1 for data and L2 for frequency, you may have to arrow over or press the second key in either 1 or 2, list 1 or list 2, depending on your calculator. Anytime you're dealing with lists on the calculator, you can do the second key and the number that corresponds with the list. If you look above the number keys on your calculator, there should be numbers in a different color, labels L1, L2, and so on above each number. You can look at the second key on your calculator as kind of a shift button that you press to activate these other colored commands. If you'll notice, there's a third option too. On mine, the L1 and L2 and second buttons are in blue. Then I have an alpha key in green that can activate other functions that are in green above the numbers and other keys. You might think of it as your Alt or Control key. For now, you just need the second key, but that is good to know for working with your calculator in the future. Now let's display the histogram. So press Zoom and the number 9, and you'll see your histogram. Neat, huh? So the calculator takes some practice, so make sure you're taking good notes and working with it as we go through these lessons. So come test time, you're not wasting time trying to figure out how to do it then. Feel free to rewind the video and go over these steps again, and always feel free to ask me questions if you have them. Okay, I'll see you on the next video.